Everybody, Dr. A here, and in this video we're going to be providing some background information on 2 and 3 force members. So let's go ahead and get started. What is a 2 force member? We're going to start with a 2 force member, then we'll talk about a 3 force member. So what is a 2 force member? Well, a 2 force member is a member that has 2 forces of equal magnitude acting along, it's supposed to say along, not alone, acting along the same line of action, but in opposite directions. 2 force members occur when the member ends are pin connected to something else, okay? So for example, if we have a 2 force member, which again is a member maybe like this, that's pin connected at its ends to something else, and then a force develops in opposing directions. So in this case, you have this force applying compression at one end, and then the same force applies compression at the other end. Well, guess what? This force is equal to this force if there are no other forces acting on it, okay? So that's the thing. A 2 force member only has these 2 forces acting on it. And for this to be in equilibrium, these forces have to be equal in magnitude and opposite in direction. So this would be an example of a member experiencing compression, and specifically it's a 2 force member experiencing compression. Well, similarly, we could have, a member that's pin connected at its ends, and maybe it's got tensile forces acting at its ends, okay? So if we call these T this time, for tension, these have to be equal magnitude and opposite in direction. And notice they also, each of these forces, T and T, lie along the same line of action. The same was true with these compressive forces, F and F. Now, these members don't have to be linear, although most of the time they are, but they don't have to be linear. So for example, if you have, a member that has some curvature to it and it's pin connected at its ends, and let's say it's supporting a force P here and the same force P over here, notice that these forces P lie along the same line of action. This is still a 2 force member, okay? What if we had a really weird shaped member? What if we had this kind of like serpentine shaped member like this? As long as it's pin connected, and let's say that it has a force P here and a force P here, as long as it's connected with pins at its ends and the line of action of these 2 forces is the same and there's no other applied forces, that's also a 2 force member, okay? So this is the concept of it. Now, we said that we see them, when do we see them in practice? Well, a common example that we've seen before is the beam that is supported by a weightless link. So, for example, if we have a beam here, and let's say that it's pin connected at A over here, and it has a little weightless link or cable at B, and then an external hinge at C. Well, guess what? This member BC, that's a 2 force member, okay? Notice that it's pin connected at its ends, okay? 2 force member. It's pin connected at its ends, and if I have some applied loading here, what's going to happen? Well, I'm going to develop, an AY, of course, and a AX, and then what's going to develop here, where I'm going to get a link force or a cable force, whatever that is. And so what would happen over at C? Well, you'll have that same force reaction, equal and opposite. So if I were to extract this member BC, then I would have a single axial force through the longitudinal axis of that member BC, and it would have the same magnitude whether we look at it from B's perspective or C's perspective. So that's one illustration of where we would see a two-force member as part of a system. Now, what about three-force members? Well, what is a three-force member? A three-force member is a member supporting three forces with different magnitudes and whose lines of action form either a concurrent system or a parallel system. So when I say a concurrent system, what does that mean? Well, let's say that we have a member here, and let's say that it's on some kind of inclined planes, okay? And then let's say that it's got an applied force here. Let's call this F1. Well, if I develop these reaction forces, let's call this, maybe F2 and maybe F3, if the lines of action of all three of these forces meet at a common point, this right here is the point of concurrency. So this would be a concurrent system, okay? So that's what we mean by a concurrent system, and we've got three different forces that develop here. Now, what would a parallel system be? Well, that one is probably a little bit easier to visualize. If I had a member here, let me draw that a little bit better for us. And I've got, a force that is, maybe applied here and here and here. And let's say that this is maybe F1, F2, and F3. Notice that the lines of action of these forces form a set of three parallel lines. So that would also be considered a three-force member, okay? So that concludes this video, providing some background information on both two and three-force members. And we're gonna see these kinds of members show up in some of the systems we analyze throughout this course. If you found this video helpful, please hit like and subscribe, and be on the lookout for other content like this. Thanks for watching.